Derivation of the first law of indices, part 1. In this case, we shall be looking at the derivation in two ways. We shall be looking at it analytically, and of course, we shall be looking at it arithmetically. So let's look at it first from what the analytical perspective. The first law of indices states that a raised power m times a raised power n is equals to a raised power m plus n. This is what we call the first law of indices. So we are looking at how it originated, otherwise called the derivation, using the analytical method, and of course using what is called the arithmetical method. So analytically, let's assume we have an expression like this: 2 raised by 2 times 2 raised by 3. By simplification, 2 raised by 2 is 2 times 2. Then times 2 raised by 3, it means 2 multiplying itself in 3 ways. So you have 2 times 2 times 2 times 2. So finally we have 2 times 2 4, 4 times 2 8, 8 times 2 16, and of course 16 times 2 will give us 32. This particular expression could be written also as 2 raised by 2 plus 3, and that is equals to 2 raised by 2 plus 3, that is equals to 5. Then 2 raised by 5, this is called the exponent and this is called the base. That is equivalent to 2 times 2 times 2 times 2, and of course times 2, and that is equals to 32. Since the result obtained here is equals to the result obtained here, it can therefore be concluded that this expression is equivalent to this expression. So we have 2 raised by 2 times 2 raised by 3 is as good as 2 raised by 2 plus 3, which conform with the first law of indices. So this is analytical way of viewing the first law of indices. Now let's swing into action to look at it in a more professional angle or way, otherwise known as the arithmetical method. Let us look at it from the arithmetical method. We want to prove that indeed a raised by m times a raised by n is equals to a raised by m plus n. So in this case, we know that a raised by m is as good as a times a times a times and so on, times are you there? M number of places, n number of places or factors, n number of places or factors. Also, a raised by n is equals to a times a times a times and so on, times n, which is the exponent here, number of factors, number of places or factors, number of places or factors. Therefore, a raised power m, that is a raised power m times a raised power n becomes this times this, and that is equals to a times a times a times and so on, times m, are you there? Number of factors or position, n number of factors or places or position, can call it places, can call it position, times this, which is a times a times a times and so on, times the exponent here is n, we say n number of places, n number of places or factors, n number of places or factors. So therefore we say a raised by m, right, times a raised by n now becomes, are you there, taking the common factors here, which is a times a times a into bracket times are you there, m, that is, sorry, a times a times a, right, times and so on, times m, look at it here, m plus n number of factors, m plus n number of factors, number of are you there, places or factors, number of places or factors. Therefore we say a raised by m times a raised by n becomes are you there, a raised by the number of factors there is m plus n, and eventually becomes the exponent to this particular base, which is a. So we have a raised by m plus n, which conform with the first law of indices. So indeed, a raised by m plus what? A raised power n is as good as A raised power what? M plus what? N. This is the derivation of the first law of indices. In the part 2, we shall be looking at the derivation of the second law of indices. Do not hesitate to like, share, comment, and of course, watch out for what part 2, derivation of the second law of indices. Love you.